Good morning. We shall wait for the other students to come in. But maybe give them about a few minutes more.
Morning, Doctor.
Okay.
Okay.
Morning, Prof.
Morning.
Prof pakai baju UMK hari ni, Prof.
You nampak baju UMK.
Tak nampak logo macam UMK.
You pernah sampai UMK ke?
UMK, I've only been to 2. Satu dekat Kota Baru, Kuala Lumpur tu. Satu lagi dekat Bachok, the main campus.
Oh, Kota Baru. Masa bila you pergi Kota Baru tu? Kuala Lumpur tu?
In like 2 tahun lepas.
Oh, 2 tahun lepas saya tak ada lah. I was from UMK dulu. I was a lecturer kat sana.
Dekat Kuala Lumpur tu.
Kuala Lumpur.
I went there sebab I was a liaison officer for Duta Norway.
Okay.
Yeah, so she had a visit there. So I escorted her lah. Masa tu je lah yang pergi. So masa tu lah macam, you had the privilege untuk masuk dalam dewan sebagai. Kalau tak, siapa nak layan?
Dewan Keusahawanan.
It's a nice place. Tapi itulah, Prof, kecil. Sebab dah congested ramai sangat.
It's a shop lot. Rumah kedai tu. The whole campus is a rumah kedai. It's a shop lot. I think two blocks. 1, 2, 3 blocks. 3 blocks.
I see. Patutlah dia punya susunan tu macam tu.
3 blocks of rumah kedai, and then kita kepung kan, and then we make dalam design dalam tu. Jadi some people tak perasan pun it's a rumah kedai.
Memang tak perasan. I mean, they did a good job at with the interior deco. But now that you mention it, baru macam perasan all the, the things yang you wouldn't notice normally. Macam, lah macam ada rumah kedai punya aura tu.
Rumah kedai, and then dia sambung.
Itu memang busy lah, Prof.
Yeah.
It's always busy there. So many people.
It's actually near to the airport, next to the airport.
Yeah,
it's
it's very
next
near.
to the airport. Just bordering there ada pokok-pokok kelapa tu je. The other side is memang airport.
Yang dekat belakang tu kan?
The runway. Runway.
Airport tu. Tak bising ke, Prof, kalau kelas? Tak bising ke kalau time kelas?
Tak juga. Dia bukan tak bising juga. Sebab dia bukannya dekat dia tempat, if you remember, you take flight ke sana kan? Okay, tempat U-turn tu.
Oh, so yang UMK tu tempat yang dia U-turn tu je?
Tempat U-turn
tak
je.
dengar sangat lah. A bit further away. But somebody told me, a friend of mine told me, yang kalau if for master student, they don't have like a specific classroom, so they rent out macam shop lots yang dekat depan tu, yang dekat kedai Robi tu. So you would have your classes dekat the second story tu.
Okay, the shop lot dekat depan tu. Okay, dekat shop lot depan tu memang kita sewa. Yang shop lot di dalam tu kita UMK beli.
Oh.
Shop lot depan tu memang our classes di situ. And then sebenarnya tak semestinya di depan ataupun di belakang, depending on the size of the student, because kelas dekat dalam tu ada few classes dekat dalam tu, kelas besar, and then master students tak ramai, jadi they take the smaller classes.
I see. So they kind of like rent like some sort of a tutorial room lah separately for the master student.
Not a tutorial room, they rent the whole block.
Oh.
So the whole block, surau semua dekat situ. And then we have offices dekat situ, pembangunan dekat situ, klinik dekat situ.
I see.
It's the whole block. Block K though, it's the whole block.
So then it's fair to say that actually catalyst pembangunan kat situ is UMK.
Yes, boleh cakap lah Taman Bendahara tu. Because beside UMK, Taman Bendahara tu tak ada apa lah. Except for kita ada, we have the, yang tu pun student UMK yang pergi ramai yang dekat pantai, pantai timur. The supermarket di depan tu.
Betul, sebab kalau locals, kita orang memang tak pergi lah situ.
You are Kelantanis?
Yes, saya am a Kelantanis.
Okay, I was from situ juga. Bukan from situ, I sekolah situ. I was from sekolah situ. Sekolah kat Kuala Lumpur juga dulu.
Sekolah mana, Prof? Kuala Lumpur? MRSMPC
MRSM PC.
Oh, kau budak Bintara lah ni.
Ha? Masa
Budak
tu tak ada
Bintara
Bintara lagi. Masa tu mana
Oh, ya
ada
ke?
Bintara lagi. I was from Form 1. I was in MRSM Kota Baru. Then Kota Baru was from Form 1.
Oh, I see.
Hmm.
Bintara. Oh, masa tu Bintara tak ada lagi eh?
Masa tu belum ada Bintara. MRSM only 4 MRSM mana ada Bintara. There was only 4 4 MRSM. The whole Malaysia. At the point because MRSM Kota Baru is the second, first Seremban. And then 5 MRSM, my batch are the 5. And we have Kulim and Kuala Terengganu and Kuantan.
What
Only
year was
5
that from?
MRSM. Yeah,
What year was that?
I was there from 78 to 82.
Okay. 78. Belum lahir lagi.
Belum lahir lagi. Okay,
Oh,
we can start our class. Good morning to all. Because I was wondering whether you turn up or not because today is public holiday sort of dari Jadi Agong. Tapi if I was thinking pula kalau we postpone the class and then we have to find a time to set the class to replace the class. Might as well we don't have anything to do anyway. This is a MCO. We have our class. I think there are supposed to be 10 students. Now we have 7, so 3 is not in. If they can see the records or they might join in later. Okay. Today we'll continue from the previous topic. We move into business intelligence. I think because if I'm not mistaken, yeah. So last week we ended at we ended on we ended at the big data. We discussed about not only SQL, no SQL. We move into big data. Now we're talking to start topic on business intelligence. Anybody have any experience doing business intelligence or know what is this business intelligence is? Jipo, ever heard of Guan Jipo? Heard of business intelligence? Which part is the intelligence part?
Not really. We have we gather the sales figures, profit. I think that's all of it. Nothing much.
Okay, first, business intelligence has quite quite distant from artificial intelligence. So, yeah, quite distant from artificial intelligence. When you see the name intelligence, some people thought it is related to artificial intelligence. It's not about artificial intelligence. Artificial intelligence is about mimicking how humans act and think and react. That is artificial intelligence. But business intelligence is about it begins with business reporting. It begins with business reporting. So during the late 80s, we have MIS, the advent of MIS, Management Information System. Management Information System is do reporting. And then after that, with the reportings, and then some year, I don't remember the year, and then there was a development of data warehouse. From the data warehouse, from this data warehouse, we are able to do descriptive analytics. Do descriptive analytics of the past records. It is about the past record because we have done our business performance for the previous years, maybe 2, 3 years, 4 years, 5 years, maybe even 10 years. And then after we have had our business performance, we are able to analyze our previous business performance so that we can do variance analysis, we can do averaging, but a simple descriptive statistics. A simple descriptive statistic, meaning that it look at the past. And then they coined the term business intelligence. So business intelligence is somehow related. I'll use a whiteboard. So they coined the term called business intelligence. Yeah, so this business intelligence is about descriptive statistics. Yeah, back then it was called descriptive statistics, and now we call it descriptive analytics. So it is more about the past. Yeah, it's about the past performance. And we can say also current, but not so much of current, because we do not know the record that we have today. When it is ongoing, nothing much that we can get but say current and past performance most of the time. But actually, it is just past performance. No, but because current performance, how do you do? How do you know you're still doing it? And then the example is you have like standard deviations. Yeah. What else? We have mean. We have mode. But mean,
Median.
median, those sort of things. So we can have, yes, average, yeah. And then we'll because we have a specific course on this business intelligence analytics systems. Yeah. So this is descriptive analytics. Yeah, descriptive analytics. And then over the years, because they use the business intelligence comes with the advent of what we call data warehouse. So with this data warehouse, what can do? What else can we do with data warehouse? So from this data warehouse, because once we have this data warehouse, we are able to develop to do some further analytical. So we have data. Now that we have data, we can do some data mining. So with this data, we can do data mining. With data mining, we can have with data mining we can do associationship. Yeah, we can do clustering, associationship of one data to another data, and then we can do clustering of data, and then we can do classification of data. We can look into sequencing of the data. And then we can also do forecasting of data. So associationship is, you see, for example, like market basket analysis. Market basket analysis is something like when we buy, so the market basket analysis is the term referring to when you buy something in the same basket, there will be another thing. So when you look into the at the grocery, people buy diapers. Most of the time, they also buy baby formula milk, for example. So that is market basket analysis. People who buy, what else? People who buy, say, what else? People buy one thing, they will buy another thing together. Yeah. So those are market basket analysis. It doesn't mean it's be in the market basket, but things that people buy together. That is market basket analysis. So that is some sort of associations, meaning that a data is associated to another data. That is associations. The other one is clustering. Clustering is this data can be grouped together. There is similarity in terms of attributes. You talk about data, data is related to a certain object, and then there are attributes for that data. We talk about, we mentioned last week when we discussed about data, right? So there are attributes, similar attributes. So these are called clustering. But extending from this clustering, we have classification. Classification, we put them into a class. We have a class, for example, class Mammalia, class Reptilia, for example, they were two. Yeah, so we put them into class. The difference between clustering and classification is clustering don't have class. Similarity in terms of attributes, but they don't have class. But classification have classes. And then sequencing is about event. After event A, event B will happen. After event B, event C will happen. So you can predict the sequence. And then you can do forecasting. If this happen, another things happen. There is probability, certainty that certain level of probability that another event will happen. So these are associationships. So when we are able to do data mining, we can conduct OLAP, and we can do that other associationship, clustering, and so on. We call this predictive analytics. Yeah, we call this predictive analytics. So now we have from descriptive analytics. Historically, we also have predictive analytics. From predictive analytics, what we can do from predictive analytics, we can do what we call it simulation. We can do simulation. Yeah, we can do simulation. We can do optimization. Yeah, get my text using because there are issues of uncertainty. With these issues of uncertainty, we can use predictive modeling. Predictive modeling like simulations, Monte Carlo models. Monte Carlo models is actually they take it from the casino. So we have this simulation. We have optimization. How to optimization. Yeah. Yeah, and then we have models. We create models. Yeah. So this is called the goal of this is actually to make decision. Yeah, the goal is to make decisions. So this is called prescriptive analytics. You start prescribing. Yeah, so you start describing. This is called prescriptive analytics. So we have predictive analytics, we have prescriptive analytics, and then the term coined here is business analytics. That's why when you talk about business and intelligence and business analytics, sometimes the terminology is interchangeable. Some people say business intelligence comprised of descriptive analytics, predictive analytics, and prescriptive analytics. Some people say, oh, business analytics is descriptive, predictive, and prescriptive analytics. Actually, uh, uh, business intelligence is descriptive analytics. The predictive analytics and prescriptive analytics comes later, which are business intelligence, business analytics. But we cannot do business analytics without doing descriptive analytics, because descriptive analytics is the past. So without the past, you cannot know the future. Because how do you get the future? Because from the past performance, you look into the associationship, the clustering, classification of the data that you get from the past, so you are able to predict the future. Once you are able to predict the future, we can do simulation, optimization, and we can make models. All come from the past record. Yeah, so we cannot do business analytics without doing prescriptive analytics. Yeah. Okay, right. This arrow like this. Okay, I need to have this arrow. Okay, this arrow. And this arrow. Okay, then I think we move to our slide. Okay, any question on this? What is business intelligence? So the main component of business intelligence is data warehouse. Yeah, so we actually started from reporting. Reporting is an MIS. From the reporting, we can do analytics, descriptive analytics, because we have data warehouse. And then with the data warehouse, you can also do predictive analytics and prescriptive analytics. So what is data warehouse? Any question? Everybody can follow, I think. Okay.
Doctor, what
Yes.
is simulations and optimization? Can explain again?
Okay, simulation is we have what if scenario. We have sort of a what if scenario. A what if scenario, meaning that at a certain condition, when you change the situation or change the scenario, what will happen? If you change the scenario, what will happen? That is called simulation. You simulate. And then optimization, we find a point, a mathematical optimization, actually a statistical optimization. We find a point where it meets. So we have what do you call it, linear programming. You remember? We learn in school linear programming. So we have formula, and then we seek the point where is the optimized point. Yeah, we do linear. Linear programming is not programming. This is linear programming. Is the formula we learn in school, right? A plus bx plus c. Yeah. Yeah. A y is equal to a x squared plus bx and so on. Yeah. So that is linear programming. So when you do linear programming, you can get optimization. And then we also create models. Models from the things that we can define from the past records. We can create models, mathematical models, financial models. So that as such, we can have what we call, the term here is actually DSS. What is DSS? Anybody? Habibah?
It sounds familiar, but I don't remember.
Decision support system. Decision support system. Yeah, we have DSS. Okay, any other question? It's good for you to ask, so that I might miss out something. Anything? Habibah, Tan, or Alia, Najwa? Okay, so then we move back to our slide. So business intelligence, we have some array of tools in obtaining information from the separate systems and also from big data. Yeah. From big data also we can use. Because from big data, there are you must bear in mind that 85% of those in big data are unstructured data. So we need to transform them into structured data, and then we can process them. And some of them are semi-structured data. And then the main component of business intelligence and even business analytics is data warehouse. This data warehouse stores the current and historical data from many core operational transaction system because they collect the data from the TPS, transaction processing system. Yeah, recall we talked about transaction processing system in the previous class, and then they consolidate and standardize the information to be used across the enterprise. But this data cannot be altered. You cannot change any point of this data. Okay, can you imagine how data cannot be changed? This data cannot be changed. So how if there is any update of the data, how could it be made? The term is here is there is a term we call it non-volatile. Where is my text? Okay, we call it non-volatile. Non-volatile meaning that data cannot change. Once it is there, it is fixed, permanently there. Anybody comes from accounting? The bachelor is accounting or degree in accounting or doing accounting work.
Me, Doctor.
Okay, how can accounting records be changed?
No.
So how do you update accounting records when there is an error?
Insert enter new data.
Enter a new data. We do reversal entry. We do corrective entry. We do another double entry. So once we have mistakenly credited somebody else's account, what we do, we have to debit it and then credit the other person's the new person's account, for example. Yeah. So the record will stay in the data. The record will stay. So this is how data cannot be altered. It's not, that doesn't mean that data cannot be updated. It can be updated but cannot be altered. You cannot just change the data. Today it is 89. You made an error. Actually, it was supposed to be 99. How do? You have to either put an entry to reverse 10 ringgit, or you pull out the whole thing 89 and then you put another entry of 99 ringgit. But the 89 ringgit that you have entered earlier is permanently there. Yeah, you cannot change. Anybody want any question? Okay, I think that is because all of you are from business side, you should know that data cannot be changed. Yeah. So it provides, because it is illegal actually to change the data. You are manipulating illegal manipulation of data. So data warehouse also provide analysis and reporting tools. Depending on the level, it can be descriptive, it can be predictive, or it can be prescriptive analytics. Okay, detail of this we cover in our elective course, business intelligence. Okay, okay. Besides data warehouse, we also have another sort of warehouse, similar like warehouse, but we call it data marts. Data marts are small scale data warehouse. It's a small scale data warehouse which are subset of data warehouse. Actually, when you develop data warehouse, there are two ways to develop the data warehouse. Whether you develop it from the mart or you develop from the data warehouse, top down or bottom up. Okay, data mart is meant to cater to specific field or specific focus or specific function. So, for example, we have the main data warehouse for the whole organization, the whole enterprise. We have a data mart for finance, for example, just to cater for finance, or data mart for costing, or data mart for production, or data mart for a specific project. We have a small data mart. So that when we want to do analysis tools, when we want to do analytics, we don't have to fetch the whole data. We can process the data at the data mart. So it will be much faster. And then, so it is more efficient and effective. There are two types of data marts. Actually, they are independent data marts, independent data marts. But most of the time, data marts are dependent. Okay. And then besides that, there are also tools like Hadoop tools. We have HDFS, MapReduce, HBase. These are tools that meant for big data. So they can do parallel processing. They can do breaking a data into cluster. And then they don't use relational database. They use NO, not only SQL, no SQL database. Yeah. So these are the tools that we have in as the business intelligence infrastructure. And then there are currently they have this in-memory computing, especially for big data analysis, because if you keep on fetching data from the secondary storage and moving, going back and forth, it will take time. Yeah. Today, even though today we have we don't use the mechanical storage anymore, but still in-memory computing is much faster because they use the computer's RAM, main memory for the data storage. So everything is put into the RAM and then they retrieve uh, in what random access. Yeah. So it will reduce hours and days of processing to seconds, and then you require optimization of hardware, meaning your hardware must be optimized. And then there are analytic platform, high-speed platform using both relational and non-relational tools, relational database and non-relational database to optimize for large data sets. So this is some diagram of example of how we have business intelligence. We have operational data. From operational data, what do we have? We have TPS. What is TPS? Transaction processing system. From this transaction processing system, we have tools to do the extract, transform, and load. Put the data into data warehouse. The data is readily in the data warehouse. And then we can have also some of this operational data from this MIS can also be passed to the Hadoop cluster. And then we also have historical data from MIS passed into the Hadoop cluster. We have machine data, for example, we have IoT, we have RFID, and others, machine data. Today we also have QR code. Yeah, people fetch QR code and then straight away can be sent to the Hadoop cluster. And then we have web data coming from the web. We have web mining, audio, video data, external data from other legacy system. Maybe you have a legacy system or any other system move into the Hadoop cluster, and then from this Hadoop cluster is meant for big data. Yeah? So we can push it to the data warehouse. So we have a large data warehouse, and then we can push some of the content from this data from this data warehouse to specific data marts. We may have a data mart for finance or data mart for marketing. And many more. So there will be the different data mart. So these data mart are dependent to the data warehouse. They fetch data from data warehouse so that they can do individual processing. So finance, they can do their own. Marketing, they can do their own. So they don't have to process, except for things that you need to process cross functional, then you will process it data warehouse. Those that you don't require to do cross functional, you can do it at data mart. So from this data mart, we have the casual users who do queries. Queries can be done using SQL, structured query language, and then there can be standard reporting. And then we also have dashboard. And then, okay, this part is what we call OLTP. Online transaction processing. This, and then compared to this part, yeah, is more analytical. So this part we can have a descriptive analytics. Descriptive analytics are just actually statistics. Yeah, it's actually descriptive analytics are descriptive statistics. Descriptive analytics and descriptive statistics are interchangeable. You calculate the mean, the mode, the median, the average, the standard deviation, and calculate you show the histogram, the graph, and so on. Yeah. But when we talk about analytics, we are more towards predictive analytics and prescriptive analytics. So we have analytics platform here. We have analytical system. So that we can provide query or reports, we can have online analytical processing instead of OLTP. This part we have, this is OLTP, online transaction processing. Here we have online analytical processing, and also we can also do data mining. Data mining, like I mentioned just now, associationship, sequencing, clustering, classification, and then we can do optimization, we can do simulation, we can do modeling, and so on. So we can design our models. Yeah. So this is usually faster. OLTP, the casual users are faster, but analytical part is it's not things that you. Of course, there are some basic reports that you can request to be done. What they call it, periodically, but they most of the time they are requests for ad hoc by top level management. Okay, there is a project that we want to do, or even tactical level management. That is tactical level management or top level management. If they want to acquire a company, they want to invest into another company, and then they look into how we can synchronize or align our activities with the company. Are there any relationships? Will there be any conflicts between our companies and the other companies? We want to do decision making, so we can have a decision support system. Yeah. Okay, any question?
Doctor, what is the Hadoop cluster?
Hadoop cluster is for big data tools. This is the Hadoop cluster. Go back to the previous slide. Okay. Not this slide. Not this slide. Okay, this is the Hadoop cluster. There are several. Hadoop is actually an open source system. Hadoop is an open source system. You can get it for free, install it, and then wait, I need to make this. Here. Okay, it is a open source system. It belongs to Apache. Apache. The term is the group is called Apache. Apache Hadoop. Hadoop is a group of products that comes under the Apache cluster, Apache research cluster. Yeah, it's actually an open source. It is an open source.
Are there any other software that works like Hadoop? What Hadoop is like a brand name kan? I mean,
Hadoop is a brand name, but one thing about Hadoop is free.
Oh, tapi kalau yang lain?
Yang lain ada, kalau there are others I think that can deal with big data, but so far not as good as Hadoop. And then when Hadoop is free, who can beat a free product?
So Hadoop is a type of
Hadoop is actually Hadoop is actually a group of research team. Okay, I'll show you the site. I padam dulu. If confused dekat. We move into the next slide. Yeah. Okay, ke sini nanti I stop sini. It is under Apache. Okay, I'll share you. Where do I go? Okay, I'll stop share dulu. I'll open up the site. Hold on. Hadoop is quite prominent for open big data. Okay. Actually, when you talk about IT, yeah. Alia, you come from IT background, right?
Yes, dalam IT
You
dengar juga pasal Hadoop ni tapi still tak faham juga.
Okay, dia biasa pakai Apache tak?
Tak juga sebab kita orang mainly infra side. So hardware je.
Yeah. Okay. Yang sebenarnya actually kalau I come from the software side. Software side, the fastest development of software, the most rapid development in terms of software is at the open source.
Betul.
It's not the commercial. Commercial is slow. Commercial usually duplicate what the open source have. For example, we have Protege developed by open source to do knowledge model. I am a knowledge engineer. And then we have Apache and we have Protege, and later on we have Top-Rate Composer. Top-Rate Composer is a commercial product, but Protege is a free product. Okay, but when in terms of functionality, Protege has more functionality, but in terms of what do you call it, capability to, or okay, you can say user friendliness to lay people, and then you can say Top-Rate Composer is more user friendly. Because most commercial product, they tend to target for non-techie, right, Alia?
Betul.
Not most user product argument. In terms of server as well, this is Apache server. Apache, if you heard of Apache is a software foundation. It is a community-led development, the Apache way. So it is the largest open source foundation. They have a lot of products here. So if you name it, there are a lot of things that Apache have. There are and they have Apache with these are the products by category. Yeah, Iceberg, HTTP is the server, Hadoop is here. So these are the list of products developed by in the group Kafka. Yeah, so these are prominent XML. Yeah, these are prominent IT software, but most of them are actually all of them Helix, yeah, open source. In terms of software, open source is the largest community compared to any commercial community, and then they are the most advanced. Cordova most advanced compared to any commercial community. Commercial is coming later, and then this is Apache Hadoop. Apache Hadoop is open source. Of course, I don't find anywhere yet that commercial people develop. This is a product of big data, yeah, Avro, Cassandra, HBase, Hive. Yeah, these are the product. Because so far I don't find any big data tools that come from commercial. It's not easy to develop commercial when we have things which are free. Yeah. Okay. Any other question, Alia?
Okay. So it's it distributes. Yang ni lah maknanya for the distributed processing of large data sets across clusters of computer.
Yes.
It's a programming model.
It is because actually Hadoop comes before big data actually. Before people coin big data, because I have been using Hadoop before we come up with big data. So where does big data come from? Big data comes from because of Hadoop. It is not that big data come, then only Hadoop is created. Big data is in the picture because Hadoop is there.
Prof, does it mean that Hadoop is a software that That means it gathers all the information and it distribute to many other computer in order to use their processing capability,
Yes,
something like that.
yes. Because I require some time Hadoop. Say learn more about Hadoop. Hadoop is quite been there quite some time. I see. I don't see the history there because I recall that I have been experiencing, I mean, experimenting Hadoop for quite some time before they even have this. Before people talk about big data, and then big data actually come into the picture because there is tools to do it, because there is Hadoop. Yeah, because without Hadoop there is no big data, because Hadoop come before big data. Get what I mean? Because without Hadoop, how to do big data? Big data come into the picture when there is Hadoop. And then besides Hadoop, big data, because there is also another technology, we call it natural language processing. Yeah, okay, I'll share my whiteboard again. There is another technology. Okay, this is clear, so I can clear this. For big data, we have Hadoop, of course. Hadoop is actually a processing system, a data processing tools. Hadoop, it can process the data. But we know that there are, so what is big data? Big data comprise of, big data is coined by, I don't remember who coined the term big data, but it started with 3B and then become 4B, 5B, 6, yeah, 7B, 3B. What is the 3B of big data? Anybody can say? Emmanuel? It is volume,
Variety,
the 3B first, yeah, that's 3B. Variety,
velocity.
velocity. So data come very fast, data have large volume, so it can be catered by Hadoop. Yeah, but there is an existing technology that comes before Hadoop. Before Hadoop, there is already a technology called natural language processing. So when we have natural language processing, language processing is already there. And then with the advent of Hadoop that can handle a large size of data, so we can cater for this volume, we can cater for this variety. Yeah, this is for handling 85% of unstructured data. So these cater for volume and variety, volume and high speed of data, velocity of data. So it make big data analytics possible. What is big data? Okay, this is big data analytics. I'm talking about big data analytics. What is big data? Where does big data come from?
Come from everywhere.
The big data come from anywhere. Why suddenly we say, okay, we have this big data and then we can make use of this big data? What is the event that that generates this big data? What is the event that generates big data?
All the online digital activity and digital footprint.
Yes, when we have many online, when we have internet, when we have many online activity, especially when we have social media, so the data become big. And then how do we analyze the big data? And then we see, and then Hadoop start analyzing volume and velocity of data. Say, okay, we can use this. And then how do we take up 85% of the unstructured data? We already have a kind of natural language processing. We combine this and then we have the big data analytics. Okay, any other question? Just ask. Okay. We have,
Prof, the 85% rule is come from where?
okay, 85% is the actually we don't know actually whether it is 5% or not, but majority of those data, we call it data scientists say 85%. You know, this assumption created by this data scientist that 85%. Okay, I assume it can be larger. Okay, what are the unstructured data? Unstructured data are video, voice, the signal that we get from our telephony, RFID, QR code. The structured data are those in the. Where is the structured data? Alia, where is the structured data, Alia? Emmanuel, you guess, where is the structured data? The structured data refers to data which is structured in the computerized system. In the computerized system, meaning that we have data structure. You belajar data structure kan, Alia?
I tahulah ada structured and unstructured data, tapi kita orang punya macam selalu cakap pasal unstructured data je yang bersepah-sepah kat luar tu, meaning that it's not
yang bersepah-sepah dekat luar, because the structured data are only those in relational database.
okay.
In relational database, what is relational database? Which is those data which are in the database. Okay, what about data in the computer, but say dalam e-books? Is it structured or unstructured?
Unstructured.
Unstructured. Data in e-books are unstructured. Data in emails are unstructured. Data in any other form are all unstructured, except for those data which is properly structured in, say, you have an XML, you have, because unstructured data and structured data are computer scientist terminology. When they say structured data, structured which we can process, which the computer can process, which the data that the computer can process. So you think it's 85%? I think it's larger. By over time, when you have a lot of posting into Instagram, post into what else? Twitter, post into social media, it can be larger. But it always been 85% since whole time say 85%, 85%. That's why I repeat 85%. I'm not sure how much. Good question, Emmanuel.
Prof, kalau macam tu, what about data yang dalam apps macam My Sejahtera? Is that considered as unstructured or structured data?
Okay, I ask you, is it structured or unstructured?
My guess is structured.
Is it computer processable? I mean computer processable. You don't require any other tools. You can directly process it.
Content that they have, like our name, IC, semua considered database kan?
Yes.
Tapi when we fill up, we say we allergic ke tak allergic ke, yang tu
database juga kan?
It depends on who the user is lah kot. Kalau macam kita yang insert the data tu, I don't think we have the ability untuk access. Tapi kalau you are the admin of that app, I guess you do.
I think if I'm not wrong, because I didn't look at the database for My Sejahtera, but if I'm not wrong, My Sejahtera is structured data.
Yes, I think it definitely should be structured, so that, because if it's not structured, the government no use of having it, because they can analyze where's the hotspot and stuff.
Kalau unstructured, they cannot process it immediately.
Because they have a unique ID like IC number.
Yeah, so those are structured.
Yeah, tapi there's also other information dalam My Sejahtera that is unstructured. You know, the one that they update every day, how many cases.
So unstructured, yeah.
That one unstructured because you cannot process yang how many because there's a lot of different information kan in MySejahtera, ada a lot of components kan. Maybe dalam tu pun the same. 85 of it is unstructured, 15% just structured, which is all our name, IC, and
Anggur 85%.
Because logically, this is my love thinking. Logically, kalau if everything is structured, we don't have this problem of getting, the thing that when we deal with Sejahtera, they can detect us, they can know where we are because everything is structured. It's computer processable. Unless, like you said, if it is unstructured, they themselves cannot process the data. But it's supposed to be structured. It is supposed to be structured. That's what the purpose of the data is. Right. Okay. But anyway, none of us actually. Anybody working with MySejahtera? Oh, okay. None of us would know what actually happening inside them, whether they are unstructured or unstructured. Okay. Anyway, it's good question that you asked, so we can explore. Any other thing that we can move? Okay, Alia, it's okay. You asked about Hadoop just now. Hadoop is actually a group, yeah. It is a group of okay, this is Hadoop, yeah. Hadoop is this group, yeah. There is now Apache Hadoop 3.22. So in Apache Hadoop, they have this a lot of the system, yeah, cluster, the software that they have in this group of Hadoop, yeah. So you can freely download, and then companies, a lot of companies use Hadoop. Similarly, like Wiki is actually also free. Yeah. Okay. Okay. Big data engineer. Okay. We move into the next. Okay. We back here. Okay, this is we have covered this. Okay, we move into analytical tools. There are several analytical tools that we can do to consolidate. Why do we need to consolidate? Because data come in various sources, so we need to consolidate them. And then actually, before we consolidate, we need to do cleaning of the data, and then we need to transform the data, and then only we can consolidate it, analyze it, and provide access to other users. Yeah? So we have multi-dimensional analysis, with them OLAP, multi-dimensional data analysis. We have data mining, text mining, and web mining. Okay. When we talk about multi-dimensional data analysis, this is OLAP, multi-dimensional analysis. We look into data using multiple dimensions. Instead of for common database, we have row and column. So we can look at them as cubes. So this is a cube. So you can have more than one cube. This is one of the cube. You can have more than one cube. So we can have region, can have product, actual projected, and can have more. So we can do multi-dimensional analysis. We call it all that. So it provides rapid online answer to ad hoc queries. And then beside all that, we have data mining. Data mining, I have mentioned to you just now. Data mining is association and so on. And then we have text mining and web mining. Okay, this text mining and web mining are two of these handles unstructured data. So they handle unstructured data. So they use natural language processing and ontology. My area is ontology. Actually, my field of expertise. Okay, natural language processing is like I think every one of us have used natural language processing without them realizing. One of it is your spell checker. Your spell checker when you use Word, you have a spell checker. It is a natural language processing system. Grammar, grammatical checker. And then we have machine translation, MT, machine translation that translate. and then we have text to speech, and then automated speech recognition. So these are natural language processing. What is natural language? Natural language is the language that people use. So in text mining, for example, you have a document, say an ebook, yeah, they are unstructured, but we can use natural language processing. But the steps for natural language processing, what they do is actually they will remove the stop words, yeah. Stop words is like the and so those are stop words, and then you have you do this morphological analysis to do root word stemming. We call it stemming, yeah, to get so that they will get the root words, and then they will do tokenization, then they process it, and then it will become keywords. And then from the keywords, they will analyze the keywords. That is text mining. Same goes with web mining. Web mining is almost similar like text mining. They crawl the web, and then they pick up. I think okay, later on we'll discuss about search engine. Yeah, okay. Any question? Okay. Okay. Then we have online analytical processing. We have done that just now. Okay, data mining is finding hidden patterns. We have discussed about this. And then text mining, we extract key elements from large unstructured data. Web mining, and then databases in the web. So many companies use web. So we have typical configuration. We have web server, application server, database server, then we have web browsers, and so on. Okay, what is the difference between internet and the web? It came up in last trimester's examination. Alia, you come from computing. What is the difference between internet and the World Wide Web?
Internet is actually the connection. Macam I think we discussed last time kan, internet tu is actually the physical connection that connects all the information from one place to another, and the World Wide Web is the platform that we use. I'm not sure.
For you terbalik tu.
Oh, terbalik.
Okay, internet is actually a very large network of computers, a very large network computers. So, what is the purpose of computers? What is the purpose of networking computers? So it can communicate with each other. That's all. So that is internet. What World Wide Web is actually on top of the on top of the infrastructure. Internet is the infrastructure, right? It is the network of computers. In fact, on top of the infrastructure, we put information. We put information so that we can pass through information from one point to another point using the internet as the infrastructure. So, World Wide Web is the information. It's the information. It's actually it moves from server to server. The information are able to use to move from server to server. It rides on top of. So when we have when the internet comes with the advent of TCP/IP, and then after this TCP/IP, Tim Berners-Lee created what he write on top of this what do you call it packet. So he created what he terms as a browser, and then his first browser was known as World Wide Web, and then he developed protocols to communicate along the browsers, and then they have HTML markup language, created markup language. So this markup language can write on top of this TCP/IP, and then it can so that they can communicate and deliver messages across, information across. Yeah. So one is the infrastructure, the other one is the content, the software part. The software part is World Wide Web. The hardware part is the networking part is the TCP/IP. Okay. So looking at that, we have here. So when linking internet database to the web, we have client with the web browser. We require the web browser, and then we have internet, we have web server, we have application server, we have database server here and database, and then in the middle we have this domain name server actually. Okay, no question. Any question? Just ask me, and then organization require information policy.
Ada soalan satu.
Yes.
Is there a difference between a browser and a search engine, or is it the same thing?
Okay, different. Browser and the search engine are two different things. What makes people confused between the browser and search engine? What makes people confused between browser and search engine?
From a
do you
layman
think?
perspective, because I think that it's almost similar, so I don't know what is the difference between the two.
Okay, what is the first browser?
Internet Explorer.
Internet Explorer. Before Internet Explorer?
Is it Yahoo, Doctor?
Then we got confused.
Yahoo. Okay lah.
Yahoo tu search engine kan?
Search
Yahoo
engine.
Yahoo search engine. Okay, the browser previously. Okay, so I am an old person in terms of computing. I started programming in 1979. Back then there is no internet, there is computing, and then comes internet, and then comes the World Wide Web, and then the first time I use World Wide Web internet, we have a browser. The first browser actually Mosaic, MOSAIC. Yeah, the first browser is Mosaic. But the most when I started using the browser that I use is Netscape. Anybody recall Netscape? Netscape Explorer. And then we have another one, Netscape Navigator. And then after Netscape, then we have Internet Explorer. This is the browser.
Prof, there is one called LYNX. What is that?
LY links.
Links. Text-based and no graphic content.
Yes, I recall that. I don't remember, but I recall that. Explorer links, yeah. There are many more to actually system, but it is not a browser. If I'm not mistaken, links not a browser. Okay, these are called browsers.
Doctor, Mozilla Firefox pun consider?
Mozilla is a browser. Mozilla is a browser. Firefox is a browser. Firefox and Mozilla same group. Chrome is a browser. Okay. There was you can read about this, the browser war. There is a browser war. Browser war. Anybody heard about browser war? Browser war between the two browsers. Okay, there is a war. We can say court conflicts. Yeah, both companies bring up in court because Netscape, Internet Explorer put up Microsoft put up Internet Explorer in their suite, in their operating system. So it conflicts with Internet Netscape Explorer because they call it it is they have a competition act in competition law in the US, and then bring it up in court, and then Netscape Explorer lost. Internet Explorer, Internet Explorer Win, I think. I don't recall, but there is a browser war. But I think at the end, Netscape Explorer closed their shop. So before Netscape Explorer closed down, they published their browser source code, their browser source code into as an open source. So with the open source now and then, we have a lot of Opus, we have Opera, we have Chrome, because you can develop your own browser. The browser source code is freely open. Okay, that is browser. And then during the first search engine that I use is Alta Vista. You never heard of Alta Vista? Alta Vista. And then after Alta Vista, we have Yahoo. Alta Vista is a pure keyword search engine. They just look into precision and recall. But Yahoo, they apply metadata. And then we have Google. Google, they use page rank algorithm. Page rank algorithm. So these are search engines. Okay. Now the question is, why people get confused between browser and search engine? Chrome is here.
Because of Google Chrome and Google.
Because Google Chrome put Google in their browser.
So semua salah Google.
Semua salah Google. Google Chrome put, they create their browser and then they put the search engine in their browser. People got confused. Yeah, Guan Jipo provided the answer.
Basically, search engine is just something to search what you want. Browser is the one that you go into a site.
Yeah, yeah. Browser is the thing that you are able to see what is in the World Wide Web. Yeah, the search engine is the search. But there is one question we will answer later. Does the search engine search the web?
My answer is most probably no.
Okay, what does it search?
I think that a search engine is basically like a window where you just type in the keyword, but then the one who's doing the work behind it, like the back end, is actually the browser. Is that it?
No, you got confused. You terbalik.
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 Oh, tak.
Okay. Okay, tengok ya. Okay, this we cover this first. This topic. Okay, database administration. Okay, we have covered this, and then we have require data quality. Yeah. Okay. So to maintain data, 25% of the data is inaccurate. So you need to maintain data quality. So you must identify the correct. There is a process called data cleansing. Yeah, and then you have data quality audit. Yeah, that's all. Okay, the question that we'll take a break, and then after the answer, after coming up to the break, because we are beginning we're beginning to talk about search engine. The question is search engine. Yeah. You can think about it during the break. Search engines. There are many search engines, right? Today search World Wide Web. The search engine, yeah, particularly the search engine, yeah, the search engine, not other system, search engine to their system, do they search the World Wide Web? What do you think, Habibah? Yes
Because
or no?
from my for my last semester, I did a kind of like a research on Google for my exam. No, for my assignment. So yeah, these things came up. So at that time, my understanding was that, like I told you just now lah,
Okay.
like Google
Okay,
search
we'll
is just the search.
they just message. You get confused actually between the web. Okay, you give me an answer, Habibah, yes or no?
No, my answer is no. They
No,
don't search.
they don't search. Okay, Po, yes or no?
No.
Huh?
No.
No. Okay, Tan Changhua, yes or no?
I'm not sure.
Yes or no? Just put yes or no. We'll get back after we.
No good. No one.
No. Okay. No. Okay. We have many people to say no. Okay. Next. Let's see. Yeah. Alia. Yes or no?
Just for the sake of arguing, yes.
Yes. Okay. Emmanuel. Yes or no?
Saya say yes kot research web.
Okay. Najwa. Yes or no?
Yes.
Yes. Okay. No Rasmin. Yes or no?
I think no.
Okay. You have how many say no? How many say yes? Okay, 1, 2, 3, 4 says no. 1, 2, 3 say yes. Okay. Anybody else? The only two. Okay, nobody else. Okay, we'll take a break. Now is what time is now? Now it's 10. Assume this is 10:20. We'll take a break. We come back at 10:40. We come back at 10:40. Yeah. Okay. Okay, we can continue. Okay, I accidentally deleted your books. Okay, on the search engine. Okay, actually, this topic is networking and internet. We will talk about networking, and then we also cover the different packet switching, TCP/IP, signals, and transmission, satellite, cellular system, fiber optics, coaxial, instant pair, and then we also cover uh, search engine actually. We talk about search engine. So because the issue was raised before we took our break just now, so we'll answer the part of the search engine first. Yeah. Move in the search engine. So I'll open up my. This is on the search engine. Okay. Open up the whiteboard first. Okay, clear this. Okay, what does the search engine search the web? Okay, what does the search engine do actually? Okay, search engine, or the proper technical name, is actually an information and retrieval system. It's actually information and retrieval system. What is the difference between information retrieval and data retrieval? The name is information retrieval system. Okay, what is the difference between information retrieval versus data retrieval?
Information is
Habibah,
a collection of data.
yes?
Information is a collection of data.
Yeah, come again. I didn't get it clear.
Information is a collection of data.
Okay, what is information? Tidak. Information. Information is a collection of data, yes. What is the difference between information retrieval versus data retrieval?
So from that point, what I gather is that information retrieval is basically you retrieving a large pool of data as compared to data retrieval, where you're focusing on one component or one specific data only. So it's like based on volume. This one is larger, this one is smaller.
Okay, it's easier to do the data retrieval because data retrieval you point up, you point down, focus on the specific data, but information is actually a combination or an inference of several data. So it's not that easy to do information retrieval. Information retrieval, we have the term we call it recall versus precision. Yeah, for data retrieval, we can have precision, we have recall, and we have great precision. For information retrieval, we can also have recall. We have 1,000 recalls. For example, if you search in Yahoo or Google, you have 1 million, a few million of recalls, but whether it is precise or not, it might not be precise. So there is recall and precision are two different things. Okay, when we talk about information retrieval, what does information retrieval do? So we have the main thing here, we have a query system. We begin with a query system. The user will post their query. When it posts their query, it will go into the search engine. This is very simple. There are many more components inside this, but this is the basic component. We have an information retrieval system. Yeah. So this information retrieval system will search what we call here an index. An index, they will have two systems, two factors. We have recall, and then we have precision. And then from this recall and precision, they will be able to rank. Yeah, and then they will be able to rank. And then they will put up a display. They will provide a display. Display output is usually a list of URL. And display output is usually in form of a URL, universal resource locator, which is a website address. Yeah. So the user will key in their query. IRS is information retrieval system. The information retrieval system will search the index. They have recall, precision, and ranking, and then they will display the output. Okay. The question is, do they search the web? Do they search the web? The answer is no.
No?
No. They search the index. Okay, the question is, where does the index come from? I erase this verse, yeah? Oh no, this is the index, yeah? Where does the index come from? Okay, there is another system. There is another system that we call. There is a different system that we call it crawler, or sometimes people call it spider, or some people call it robot. Okay, this robot or this crawler will move from server to server. We have servers. This is with our post casing or rack of servers. They will move from server to server. Yeah, they will move from server routinely, maybe daily, monthly, or weekly, routinely. They will crawl routinely, meaning that without you asking, they do that routinely. Yeah, the term is, what is the term? They call it, what is the term? I missed my word. I need to go back to the screen. Okay. They crawl routinely. Yeah. And then once they crawl, what they do, they will update. They will update into a, what they call it, a raw index. They have a raw index. Yeah, so they will put everything in raw index after they have organized. After they have organized, they will update this into index. So there is a term what we call freshness. Yeah. Freshness is the update of the index. Once it is updated, what they will do, certain content which is outdated, they will keep into another file. They call it cache. Cache is an old file. And that's why sometimes when you open the web, when the content is not there, they will give you, they ask you whether what you want to look at the cache. This is certain update that they have. So when you talk about search engine, the search engine is this. This is search engine. Yeah, this is the search engine. Query process, they have an information retrieval system, they have indexing and so on. So, but you can create your own search engine. There are several types of search engine, but you will get data from another system that they call crawler. Yes, there are crawlers. For example, one of the crawler, open source crawler that I happen to use is Heritrix. It's a crawler. There are several crawlers that you can search. Yeah? There are several crawlers that just crawl. That's why when you fill up the your COVID, they ask you, "Are you a robot? Are you a robot?" They're suspecting that you are this robot that move and then fill up information, and then these are the robots that move. But one of these activities of this robot is actually to create an index, and then these robots have what they call it a name tag. They have a name tag. Name tag is called, the file for the name tag is called robot.txt. Robot or robot.txt. So there is a name tag. In the name tag tell, okay, I am Google. When they say they are Google, and then when they move into certain particular server, the server, oh, you are Google, I allow you in for certain area. Yeah, but there are also places where crawlers that cannot crawl, where these servers have their own crawling system. For example, like at most of the social media systems, like Facebook, Twitter, they have their own. They don't allow the external crawler to come in. They have their own crawler. So you don't see this content in the normal web. Sometimes people call it dark web and so on, but these are the web that this crawler doesn't go in. Yeah, you have the dark web, right? Because they cater for social media. The normal crawler doesn't go into certain servers. Okay, does that answer what, whether the search engine search the web or not? Search engine search the index. And then the ranking algorithm, you have this ranking algorithm and so on, is on the index. How do you rank? Because you have everything in the index, you sort the index by rank and so on. So you can have several search engines, but you can also have your own crawler, but depends on whether people allow you to enter to their portal or not, or you can just intrude your way in. Yeah. Okay.
Doctor, just have a
Yes.
question, like, because the crawler will keep crawl routinely, so we no need to update like Google to get the latest information. But why this crawler didn't exist in the apps? We need to like regularly update our apps. Then Google no need.
But our app are different things. Why? It's two different things. Our apps and crawler are two different things. Our apps are not crawler.
No,
Crawler
means,
is a specific robot that is being created to crawl around all the server in the world. It is a robot. Actually, the purpose is just to move around and then send update.
I mean, why in the apps application don't have this robot, then automatically help us update the.
Okay. Crawlers are big engine and then they require large size. If you use your crawler, say you have a computer, a server, and you start crawling, after a while, your computer will be filled up with data. They really fetch the data. Whatever they can get, they really fetch the data and bring it in. And then you need to purge. That's why they have this raw index, and then you need to purge similarity. You need to give instruction them to purge. Otherwise, they will build up, your system will jam. So you cannot ask them to update and so on, because they start crawling and then they will bring in everything in. They bring all the data that they find, they will bring into your computer. After 1 hour or 2 hours, your computer will jam. Do you want to? People don't want to do that. Okay. Because I've done crawling actually. I've done crawling. After a while, and then say, oh, I have to stop this crawling. They just bring in everything unless you give them proper instruction what to give in. And then even then, you come in and then you have to purge them. You have to organize them. Then only you build into the index. Yeah, does that answer you?
Yeah, okay. And then another thing is the information and data look like the similar things. And when we talk like, okay, we search for information or we search for data, because for me, data is like a number, like Normally manager will tell, okay, give me some data, then it's like the figure, not the words.
Okay, what is the difference between information and data?
Based on the volume.
No, information has meaning, data has no meaning. Information has meaning, data has no meaning. When you do information retrieval, you querying something with meaning. So they need to process the meaning. Yeah, they need to process. Information have meaning, data doesn't have meaning. So we can use data retrieval. What actually we don't call data retrieval. We call it query. We have data query. We use, for example, SQL, structured query language. When you learn your database the other day and last week, that is querying data. You use SQL to query data. Yeah. So you fetch the exact data. But when you do information retrieval, you don't fetch the exact. For example, when you say University Malaya, even though it is specific University Malaya, they will bring in everything about the University Malaya. That is called recall. And then precision, particularly about University Malaya, there is a precision. Precision only we can determine whether precise or not. But for them, they will call. And then how do they determine which ranking high or which ranking not low? It will be based on different algorithm. Because the Alta Vista have their own algorithm, Yahoo have their own algorithm, and Google also have their own algorithm, and then the still algorithm keep on changing. Okay. Any other question? Alia, okay, I know Alia. Any
So
question
kalau
from
macam
you?
tu, kalau macam tu kan Prof, maknanya semua search engine ni memang diorang guna ranking algorithm not just Google lah.
Okay, tak semua they have different ranking algorithm. Different ranking algorithm. They have their own ranking algorithm.
Cuma Google is the most advanced lah for now.
Okay, for Google they call it PageRank algorithm. PageRank algorithm they use backlink. Backlink meaning that they look into hyperlinks. Hyperlink meaning that when there are many hyperlinks linked to you, they assume that you are most popular, and then they rank you high. But they don't really look at metadata. They combine metadata and keyword. And for the keyword, they have this semantic entailment. But for Yahoo, they rely on metadata. Alta Vista, they use keyword, but they combine between. You can adjust between the precision and recall. So every search engine have their own method how they do the ranking. Even use Google, from time to time they change their ranking, their algorithm.
Yang satu lagi Prof, pasal cache ni kan dia kata kalau macam kita nak masuk website lepas tu tak boleh nak enter, and then dia kata boleh tak tolong clear cache and then try again.
Okay, cache ni there are dua cache. One cache is in your computer. That is what they say, want to clear cache.
Okay.
So that is the cache in your computer. The other cache here, when I mentioned here, is actually okay, say the index is 31 May. Say this is the latest index is 31 May, and then when you search here, say you search yesterday, today katalah 00706 2021. Say you search today. Tapi the index ni the freshness is end of May. Jadi during the index ni ada site dekat sini, this site ni they change their content. They change their content, say they change on the 5th of June. On the 5th of June, content to have been deleted. There's no longer content. The specific content are there. So when you query, the information retrieval system will give you an index. Yeah, index based on 31st March and 31st May. Jadi they will display this URL. Kan, URL ni will be based on 31st May, right? Kan, Alia? Dapat kan? So, bila when you click dekat URL tu, you cannot find the site.
Oh.
Sebab this index is 31st May. On the 5th of June, site ni no longer there. The site is no longer there. So they when no longer there, they will ask you the browser because especially Chrome they put their search engine dekat dalam browser. Yes, search engine. So there is two different things. Browser and search engine are two different things. So they say, do you want to read the cache? Do you want to access the cache? And then dia cari dekat dalam ni cache yang ada dekat dalam record dia. Maybe dia ada record dalam ni, dia ada cache something pada 31 bulan 5 ni. Because dia index dia 31st May kan. So they find a cache at 31st May, they give you the cache of 31st May. They will keep the cache for some time, I think a few weeks or month, and then they delete. After that, because after that you will get a fresh index. You will get a fresh index because there is they update the index. That is the cache that you get from the search engine. Search engine say, do you want to read the cache? And then when you mention just now, they say to clear the cache, clear your cache is the cache in your computer. Your computer also have a cache. Cache is a memory. Once you delete, there are the cache dalam. Sometimes this cache is interfering with your current processors. They still pick up the old data. Your computer still use the old data instead of the new data because you need to clear the cache, so you flush out the old data so they can read the new data. Okay, Alia? Does that answer your question?
Yes. Yes,
Oh,
Doctor.
that's two from cache. Any manual? Okay, No, Rasmin. Okay, now we move back to our. Okay, this is the topic in the. This is topic. This is this topic. No. This is this topic. Okay. Okay, this is the topic on the search engine. We'll come back here later. We have discussed about search engine, but there are other search, mobile search, search, social search, visual search. First we move into introduction of the networking. Okay, networking is actually today. Computers and telephone networks have converged. Before that, I think during the old days we have PBS system. Our officers have a different telephony, and then networking is a different cable. Most of major offices today, especially large offices, we don't have the PBX line anymore. We don't have Centrex line anymore. Most people are using VoIP. They have converged the telephony together with the data line. So our phone lines come with RJ45 instead of the old RJ11. RJ11 is the twin two pair cable. So even in US, the 74% of US internet have broadband access. Besides that, we also have wireless broadband. Voice data communication are taking place over the broadband wireless platform. So what is a computer network? Computer network are two or more connected computers. So major components in the simple network is we have a client, we have a server, we have network interfaces. Previously we call it NIC, network interface card, because there is a card we put in. And then there is a connection medium. There are several connection medium. It can be cable, it can be cellular, it can be satellite, it can be fiber optic. Yeah. And then it is managed by a network operating system. So, and then we have physical devices like hub, switches, routers. And then yet today there is also what we call software defined networking, where we don't have switches and routers anymore physically, but they are just software that being put up in the server. In the server, there is a software. So this software acts as switches and routers instead of physical hardware. So this is the trend that we have now. So What are routers? Routers is a system that combines two different systems. It's a tool. It's an apparatus. It's an apparatus that connects two different systems. So we have one side here. We have your local area network. Where is my drawing? Okay, this is your local area network. Yeah. And then this is the internet. Yeah, this is the internet. So router connects two systems. So we have this internet. Internet always capital I because internet is a specific name. There is only one internet in the whole world. Okay, internet and LAN, and then we have switches here that connects to several systems. We have a network operating system here. Network operating system sits in the network server, and then it manage your main switch, which manage the other switches, and then from these switches manage the connectivity to the other PCs, yeah, personal computers. So there are hundred in normally in your large corporate network, we have hundreds of local area networks linked to firm-wide corporate network. And then there are various servers. We have website servers, corporate intranet, intranet and internet. What is the difference between internet and intranet?
Intranet is within the server.
Intranet is within your organization. The right word, within the organization. Extranet is external to your organization. You may have your vendors, you may have your agents, yeah, sales agent who are linked to your network. This called extranet. And then besides that, you have also your backend system. And then within the organization also you have mobile wireless local area network or Wi-Fi network. You have video conferencing system, especially today with the pandemic, everybody use video conferencing systems. We call it telepresence. Telepresence we have. And then we have telephone network and wireless cell phone. This is an example. Okay. And then the key digital networking technologies that we have today, we have client server computing. We have a distributed computing model where the clients are connected through a network controlled by the network server computer. This is a network server computer. Where is a network server computer? Yeah, like this here. They have a network operating system installed in the network server computer. And then this server set the rules of communication for the network, provide every client with an address. So they have their own IP address. Sometimes we refer to them as local IP. It's not the standard IP that given by the telco, but it is a local IP generated for use within the organization so that you can find the connect the specific client. Client does not refer customer in this case. Client is the connection to is the PC. Yeah, is the PC, specific PC. So this client server computing have replaced this the old centralized mainframe computing, and then internet is now the largest implementation of client server computing. Okay, and then with that, internet comes into the picture with the advent of this packet switching. Before that, we have circuit switch because circuit switch network require the assembly of complete point-to-point circuit. But whereas this packet switching, we can break or slice the messages into packets or parcels, and then these parcels will be sent over different communication paths and assembled back later at the destination. So the message will be broken into smaller packets. These different packets will use different destination, the communication path, and assemble at the end. So make the system much faster, much more efficient. Yeah. So attend to more communication capacity. So besides this packet switching, the internet also made possible by the advent of the protocol we call TCP/IP, Transmission Control Protocol, Internet Protocol. It is two protocols. One is the transmission control, which organize delivery of content from network point to another network point, and then the other is the Internet Protocol. So protocol, by the way, is the rules that govern transmission of information between 2 points. And then TCP/IP is the common worldwide standard, which is the basis of the internet. Okay, this TCP/IP was created by the Department of Defense. They are the one who created the internet. Earlier, the internet was known as ARPANET. ARPANET was later decommissioned to give way to the internet in 1990s, decommissioned. So this TCP/IP comprised of this application 4 layers: application, transport, internet layer, and network interface layer. Yeah. Okay. You just stop me if you need to have further clarification. Otherwise, I just go. Yeah. So say we have an application from computer A. They want to send a message to computer B. So this message will pass through the transport layer, and then pass through the internet layer, pass through the network interface layer. The network interface layer of computer A is connected to network interface layer of computer B. And then one is switch there. This is different layer. So they will pass to the internet layer, to the transport layer, and to the application layer. As such, at the end, this computer B will receive the data sent by computer A. Okay, this is the TCP/IP reference model. Okay, there are several types of network. We have digital network versus analog network, and then we have device called modem that translate digital network into analog and analog to digital. Modem stands for modulator, but rarely we use modem anymore. Now, demodulators. A lot of homes people use wireless or router, right? Router, fiber optic routers. Yeah. So because signal coming into your home is already digital, you don't have to convert from digital to analog to digital. So the type of network we have is local area network. We use Ethernet or client server, peer-to-peer, wide area network, metropolitan area network, and campus area network. Most of these networks are not so much of the differences in terms of technical, but most of it because of their size. Campus area network, metropolitan area network, and wide area network. But at times there are different technologies that they use. For example, like WiMAX, yeah, WiMAX, yeah. For example, P1, P1. What else? There is not much of WiMAX. We have yes, yes, YES. So this is WiMAX. Okay, and then any question so far? Okay. This is function of modem, where we have digital signal converted by the modem into analog, and we have analog coming from the telephone line, cable, wireless media, or other analog devices, and then will be converted or transformed into digital to be used by the computer. Transmission media. What are the transmission media and transmission speed? We have physical transmission media. Today we have Cat5, which is the twisted pair wire. Even today we still use the current networking. We have this the cable that being used in Malaysia before this is RJ11, the one that we use in our phone, the old phone, where the people rarely have phones at home today, or RJ11. RJ11 is the network cable, and then we have this UTP cable, Cat5, Cat6, yeah. So this is the twisted pair, yeah, Cat5 and also Cat6, Cat6 UTP cable. And then coaxial cable. What is the coaxial cable? Anybody have seen any coaxial cable?
A cable is internal and outer conductor.
Yeah, the one that you use in your at the back of your television. For Astro, there is a main core, and then they have a shredded wires surrounding it. That is the coaxial cable, the one that you use for your telephone and for your television. That is your coaxial cable. Fiber optic cable are made of glasses, actually silicon. So it's the one that you use for Unify or Maxis fiber. These are fiber optic cable. And then we have wireless transmission media. We have satellite. We have cellular system. Satellite. There are two different. Okay, I'll move into satellite. Talk about satellite. Say we are clear this. Okay, there are two types of satellite. We have point-to-point satellite. Yeah, point-to-point satellite, and then we have point to multi-point. Point to point, my point to multi-point satellite, I also call broadcasting satellite. Point to point are more like telephony. So for point to point satellite, point to point satellite, one point communicates with the other point. Yeah. So we have say we have a satellite here on Earth. Say we have here. Yeah, and then there is a satellite. I do not know how to draw satellite, but I'll just draw a box. Say, assume this is your satellite. Okay, it will send messages up. Remember, for satellite, we have a term we call it line of sight. Without sight, they don't communicate. Yeah, and then it will point to, for point to point, this is point to point. So they will have another point here. Okay, there's another point here. So it will communicate to this point. This is point to point. But whereas when you have a multi-point to multi-point, so you can show people in, so this step start with point. So point A, person in point A will be able to communicate with person in point B. This is point to point. Point to point, example of point to point are like, give me an example of point to point that you know. Iridium. Anybody heard of Iridium? It is the satellite phone. Satellite phone, Iridium. We have Suraya. Suraya is the Middle East, belongs to UAE. We have Asia Cellular Satellite. Asia Cellular Satellite, I think jointly owned Indonesia and Philippines. And then what else? We have Global Star, Australia. What else we have? We have Inmarsat, International Maritime Satellite. Okay, this is point-to-point satellite. And then, but when there is another satellite that covers a broad band, covers a range of area, it covers it covers a it doesn't cover the specific point, but it covers a broad area where everybody here receive the same signal. Here. So everybody receives the same signal. But we have decoder to control. So this is point to multi-point. This is broadcasting satellite. Broadcasting satellite, example of broadcasting satellite are Miasat. What else? Palapa. What else? Tiongsak. What else? Razaksat. And many more. There are more point to multi-point. Weather satellite, GPS, global positioning satellite. So it's meant for other purposes. But point to point is more towards telephony, where people can communicate with each other directly, similar like using a phone. Okay, there are two types of satellite. We have a satellite that maintain a specific coordinate. What do we call them? We call it geosynchronous satellite, GEO, or we call it geosynchronous satellite. Geosynchronous satellite, and then we have another satellite that they are a group of satellite, not a single satellite, but a group of satellite that rotates the Earth in maybe say an hour or 2 hours. They are able to rotate the Earth, but there are many of them. For example, like Iridium have about 48 satellites, if I'm not mistaken. Iridium, and then the Global Star, similar, for 24 satellites. But for geosynchronous satellite, they don't have many, 1 or 2. For example, like ASUS only 1, Suraya only 2 or 3 satellite. But the LEO satellite, there are many of them because they are not fixed at the specific coordinate, so they rotate the Earth. We call it LEO satellite, low Earth orbit satellite. Yeah. Okay, these are some basic about satellite. So, any question?
These satellites mentioned ni, this one not Malaysian saja ke? Because Miasat is Malaysian, Razaksat is Malaysian. Yang lain ni?
Palapa Indonesia.
Oh, okay. Kalau ikutkan global satellites lagi lah banyak kan?
Global satellite banyak lagi.
Okay.
Then, but most of them are broadcasting. Broadcasting satellite banyak, but point to point tak banyak.
GPS is considered a low Earth orbit, right?
Yes. Emmanuel? Or who is asking?
Yeah, I'm saying GPS is the low Earth orbit, right?
GPS is a low Earth orbit, I think. Yeah. Okay, what is the GPS that we use for our that we use in our phone? Is it satellite based or what?
Internet.
Internet?
Internet plus GPS.
Internet plus GPS.
Yes.
Correct. It's internet plus GPS because they don't detect our phone. Actually, they detect the radio base station. And then we'll move into, yes, any other question?
Kalau Prof, kalau banyak-banyak satelit ni, how far they are from Earth, and it's like crowded lah dekat atas tu dengan kapal terbangnya.
Memang crowded but at different height, at different position, at different height.
Not higher than aeroplane.
It's higher than aeroplane. Aeroplane tak sampai situ.
Yeah, kan dia orang ada kata how there's actually a lot of space trash.
Yeah.
Because from all the space yang tu kan, every time they berlepaskan and then they cabut one part, it's all in still there out there.
Actually, I am a supplier of a satellite system. I supply Asus. I supply Asus in Suraya. I supply Asus in Suraya. Have you seen a satellite phone? Anybody have seen the satellite phone?
No, only in movies. Tak tahu
Okay.
betul tak tu.
Okay, hold on. I'll take my satellite phone and just show you.
Yes.
Okay. Yeah, I'll share. Dah berabuk dah. I used to supply Asus in Suraya. This is Suraya. Yeah. Suraya is for those who know Arabic, it is Alif Ba Ta Sa. So it pronounced as Suraya. So this is similar like this is a satellite phone. So meaning that without the cellular communication, I can this is we can still communicate. So they use huge HUGES. Huge is the satellite.
Oh,
Satellite
so
system.
this is what happens kalau macam if, for example, for countries at war, when their telecommunication tower semua jatuh, runtuh, kena bomb, so you can still communicate.
Yes.
Okay.
Okay, that is satellite phone. Okay. Now we move into now. Any question on satellite before we move into cellular? Cellular, everybody knows. Everybody have seen a cellular phone? Okay, we'll move into. Okay, besides that, we have cellular system. Cellular system, actually, by the name, actually, they comprise of cells. Yeah, the cellular actually means cells. Okay, I'll clear this. We have cells. We call it cell. This is cell. There is another cell. There is some cells are separated. Yeah, so we have, for example, we have cell in Kajang. We drive and then we find the cell in after Kajang. Where do we go? We go to say Sepang, Sepang, and then there is another cell say in Banting. This is assuming that Sepang and Banting are separated. So the cell are separated. Actually, the cell gets smaller and smaller when you move from 3G, 2G, 3G, 4G. The cell gets smaller and very small. 5G more smaller. So the cell getting smaller and smaller, but getting more bandwidth. Yeah. So when you drive from Kajang, you move, and then when you get to in the middle, they will move. You will transfer to another cell. But when you arrive here, you have a drop call. You will lose communication. That's why when you're driving, sometimes you have drop call, and then you get it back. Yeah. So that's this is cell. And then when you talk about when Emmanuel said about just now, Guan Jipo mentioned about GPS. GPS is you're measuring the position of the radio base station. We have RBS radio base station because it is a radio wave. It is a radio wave. So we call it radio base station. Radio base station is the tower that sometimes they put on top of the building. Sometimes this a standalone tower. Yeah. So so they measure this coordinate from this radio base station, yeah, another tower radio base station. So you are here, for example, you are in the middle, and then this radio base station have their GPS positioning. So with this GPS positioning, they can detect your GPS, say about around 4 meters minimum, maximum. The smallest they can get accuracy is 4 meters. I don't think they can get smaller than 4 meters, unless if they can go for difficult, because it's actually it is triangulation from the different radio base stations determining your position.
Prof, I think can get less than 4 meter. Last time we used before GPS that get up to 1 meter, down to 1 meter difference.
Now we can get 1 meter.
I think so.
Can we get down 1 meter now?
Last time we have a GPS in our car that track down to 1 meter.
That one is GPS satellite. They went in the car, the one, I think the old car like Honda and so on, they install GPS. They are tracking your car using the satellite. It's not the cellular. But the one that we use today, installed in our app, is the cellular base. We combine the cellular and the accuracy is not exact. But the car, it is exact. It's actually, even the military GPS is much more accurate. They can detect straight away. Even those who use for surveying, land surveying, they also use GPS, get coordinate. So when you measure your land, it is on the using the satellite. Yeah. So that, but GPS actually is satellite, but the one that we use in our phone is actually inferring the satellite information combined with the globe RBS. Okay, any other question on cellular? Think okay, yeah? Okay, we move on. Okay, this is cellular. So this transmission medium have speed. It is bits per second. Bit is 8 bit 1 byte. Yeah, and then we have hertz is actually bit per second. And then there are bandwidth. Bandwidth is like 1 track or 2 tracks, triple track of a highway. So it's a broadband. So internet is the world's most extensive network. It is a single network, actually link every system that there are now. So we have internet service provider that provide the connection. There are different types of internet connections. We have previously we have dial up, but I think today I'm not sure if anybody still use dial up 56.6 kilobit per second. And then we have digital subscriber line. The most famous digital subscriber line in Malaysia back then is Trimix. Trimix is offer two types of subscriber. Two types. What are they have this ADSL, asynchronous digital subscriber line for the home user. For corporate sector, normally they give this as DSL. I started my business by selling streaming. Actually, I was appointed by Telecom Malaysia. I deal direct with Telecom Malaysia. I sell broadband. I sell satellite phone. So besides that, we have cable internet connections. I think in Malaysia we are starting to have Astro. Astro is providing cable internet connections. You have connect cable because Astro is part of it's related to Maxis. And then we have satellite, and T1, T3 is the main line. They have submarine cable. I think we discussed about submarine cable previous class, right? And then okay, internet addressing. We have current addressing. We have version 5 and version 6, and then we also have version 4 still going on. Okay, the version 4 and version 5, they comprise of 32-bit number. 32-bit number maximum is 255. This is 8-bit. This is 8-bit. It's 0101, 0101 because 8-bit if we multiply 8 bits using the binary number, you will get maximum of 255. So maximum will be 255.255.255.255. The minimum will be 0000. So that is the maximum permutation that you can get using an IP address. That's why we have they have created the IPv6. We coming up with the IPv6 made it possible for us to have IoT, Internet of Things, where all devices will have their own IP address. So we might not require any local IP because we can use we can provide IP to everything, even things. So, but um, Team Berners-Lee actually created this domain name system because it's difficult for us to remember because this domain IP address similar like telephone number. Even us don't recall some telephone number today. So they created this domain name system. Domain name system have a registrar. The registrar is ICANN. ICANN maintain all this, and then we have sub-registrar. In every country, we have a sub-registrar. So they maintain. So in Malaysia, it's controlled by MyNIC. In Malaysia, the domain name system is controlled by MyNIC. MYNIC. It's under Ministry of Science. So this domain name system ties up. There is a registrar that links to specific IP addresses, and then you can, if you change your IP, you need to update. Because otherwise, they will not find your server. So this domain name system is in hierarchical structure. You have top level domain and so on. So this is show you this is example of domain name system. So the internet root domain, the top level domain, second level domain, third level domain. I am also a reseller of domain names. Okay, then we have network service provider, they provide network, and then regional telephone, and then we have professional organization, IAB, Internet Advisory Board, and then ICANN, which is the registrar, and World Wide Web Consortium. W3C is World Wide Consortium that maintain the standard like HTML, XML, XHTML, and then we have many more. This is a standard basic internet network architecture. We have the main backbone, regional hub. For mail, we have two types of mail protocol. Today, post office protocol is MTP. Post office protocol is like Outlook is using, Microsoft Outlook is using post office protocol. And then SMTP, like Gmail is using SMTP. The difference between POP mail and SMTP mail is POP mail it works like a post office. POP stands for post office protocol. It works like post office. So it's like a post box. When you collect letters from your post box, after you have collected, are your letters still in the post box? No. That's how post office protocol works. If you retrieve your mail, the mail is no longer there. It saves the storage size, storage space, data storage space. Whereas the SMTP will be accumulating, and then you need to select data which we want to delete. Okay, and then we mentioned to you about IPv6. IPv6 is alphanumerical. It is 128 bits, and then it is alphanumerical, meaning that it has numbers and also alphabet. So it is a new addressing scheme for internet numbers. So there will be more IP address. So that with that we have IoT. IoT is when you can give devices with their own IP address, which made it enable to have M2M, machine to machine communication. And then we have also this Web 3.0. We'll discuss about Web 3.0 later. Yeah, Web 3.0. And then today we also have Internet 2. And no, Internet 2 not yet. It's I'm not sure update. Internet 2 is actually a new internet they implementing for university business to develop a broader band network. Still testing. Okay, for internet services, the basic internet services that we have today: email, chatting, newsgroup, telnet, FTP, World Wide Web, and then we also have the voice over IP, packet switching. This is the basic internet, client server computing on the internet. Okay. And then we also have unified communication where we integrate voice, data, email, conferencing into one network. And then we have a virtual private network, which is a secure, encrypted private network running over the internet, point-to-point protocol, peer-to-peer protocol. This is how VoIP works. VoIP works by the term we call it a reborn voice. What is reborn voice? When you talk over the phone or using any IP telephony, it will be converted into digital. This digital will pass through into the internet, and then it is digital from here, and then from digital, they will recreate your voice. This is much more clear, but it is not the analog voice because here is analog, but they will recreate the voice. We call it reborn voice. Okay. This is peer-to-peer or virtual private network. The web runs. There is a protocol for the web. We call it hypertext transfer protocol, and then the language is being used to deliver the content so that the browser are able to understand and then translate the content over the web. Is called hypertext markup language. Besides that, we also have XML, extensible markup language, where we talk about, if we say about, we discuss about web services. Web services are using XML, which is an extensible markup language. Yeah, for machine to machine, for example. And then hypertext also contain a uniform resource locator. In search engine, the one that help you to, when you click, you can see, they are brought to the other server content is the URL that have been placed in the as hyperlink in the content of the output from your search query. Yeah, and then you have web server, which is the software for locating and managing web pages. Among the most prominent web server is Apache HTTP. We also have Windows web server, or we have IIS, yeah, and then other web server. Okay, then we move into searching. We have covered search engine, Google page rank system. This is Google page rank system where the user will enter query, and then they will receive query, and then this request will send to the Google index. Yeah. So the index, this is the index, and then the index they will use the PageRank software, and then they send a summary to the user. So where do the index mean? Because there is another system that updates the index. Yeah. So we have a crawler. Yeah, we have a crawler here that updates the index. Updates the index. Yeah. Okay. Besides, besides the search engine, the crawler also provides content to other tools. For example, mobile search. You can do mobile search. You can also do semantic search. social search, visual search. Visual search you combine with artificial neural network, so you can have image recognition. Yeah? We have the technology is called ANN, artificial neural network. Sometimes we call it neural network in some books, but I actually the term is artificial neural network. The neural network is the human being neural network. We have axon and dendron where our neuron and communicates with not within each other so that we can that is neural network. But what we're talking about is artificial neural network. Artificial neural network is in the computer. But I see that when I first this is part of it, artificial intelligence. When I first learned about artificial intelligence, we always call it artificial neural network. But I see some books today drop the term artificial. They just say neural network, neural network, neural network, and then they get confused. Which neural network, the human being or the computer? We call it artificial neural network. Yeah, and then using artificial neural network, we call it convolutional neural network. We will be able to do image recognition or what do you call it? Pattern recognition, so that we can do visual search and visual lab. Okay, now I want to bring you to semantic search. Semantic search. What does it mean by semantic? What does it mean by semantic? Anybody want to try? Emmanuel? Najwa? Tan Chauhua?
To humanize computer language.
Humanize computer language. Okay. Semantic, okay, I'll tell you. Okay, it's different. I'll use the whiteboard. I like to use whiteboard. Okay, I clear this. Okay, there is a study, we call the study semiotic. Semiotic is study of signs. Signs and symbols. Study of signs and symbols. Because human beings use signs and symbols. Don't we use sign and symbols to communicate? Of course, we use sign and symbols. Words are symbols. We have concept. We name it as term, and then it is words. Words are actually concept, which are sign and symbol. So at the bottom of this semiotic, we have syntactic. Syntactic is the rule of the language. Rule of the language, but we have in rule of the language, we have the word, vocabulary, and the grammar. So this is study is called syntactic. Okay, and then on top of the syntactic, we have the term called semantic. Semantic is, we call it about meaning. Meaning, it's about the meaning. Okay, let me see. Okay, say, Mr. Ganjipo, say, your boss call you, say, please bring me the table. What do you bring?
Table.
What table? Furniture or the paper printed out? Which one?
No, need to ask him.
I need to ask him. This is an example of where we have a specific word but have two meanings. Okay, the meaning is called semantic. So meaning that a word, a syntactic is syntax. Syntax that have two semantics. Syntax that have two semantics. That is just an example. There are many more. You can find many more words that have multiple meaning, multiple semantics. We have syntax that have multiple semantics. So, and then the other one is, okay, Then when you talk about semantic search, search by the meaning. It's not keyword search. Syntactic is keyword search. Yeah. Keyword search is semantics. Keyword search is syntactic. Semantic search is not by keyword, it is by the meaning. We call it semantic search. Yeah, it is by the meaning. How do we find the exact meaning? And then actually on top of the study of semantic, on top of semantic, we have another one, we call it pragmatic. Pragmatic is you include the context, you include the time, you include the space or we call it location. So at different time, at different context, at different location, a specific word, even though they have specific meaning, specific syntax, but it might can be interpreted differently. We call it, this is more towards interpretation. Can be interpreted differently. So we have this this is interpretation, this is meaning, and then this is actually syntax or keyword. Syntax, for syntax or keyword. So syntactics is more of syntax keyword. It's about the rule of language, vocabulary, grammar that you use. Semantic, so different words. Where one word may have different meaning. Even say maybe there are different words but have similar semantic. Yeah, and then but pragmatic is about interpretation. When you look into context, time, and space, there might be different interpretation. So that's where you move into data, information, and knowledge. Okay, for Muslim, it's really particularly for Muslims, so we have our exegesis. Do you recall exegesis? I think Christian also have their exegesis. Habibah, have you heard of exegesis?
No.
Alia?
Exorcist pernah lah. Exorcist
Exorcist.
tak pernah.
No, baru nak cakap macam Bipa exorcist pernah.
Exorcist.
Exegesis ni dah cakap Arab dia tafsir.
Oh, okay.
Okay, tafsir. When we do tafsir, it is pragmatic level, meaning we interpret. Interpret cannot be meaning. Interpret is not meaning. Interpret is you look into the context, you look into the time, you look into the space or location. So the exact time interpretation is different. Then the meaning, that's why we have asbabun nuzul and so on. So we want to have the exact pragmatic instead of semantic or syntactic. So this study is called semiotic. Okay, it actually apply in IT, also apply in other fields. So when we have our semantic search engine here, when we talk about semantic search engine, we have not yet gone into pragmatic, but we are at the semantic level. But we are no longer at the keyword level. When we talk about search engine keyword, okay, there are search engine that keyword, but that is the past and maybe current. Future, we are moving into semantic search. Semantic search is what we have today. We have web 3.0. We will discuss web 3.0 later. Web 3.0 is the semantic web. We call it web 3.0 is called the semantic web. Okay. Now we move into the next. Okay, besides that, we have intelligent shopping boards. Intelligent shopping boards are also like crawlers. They move and then gather information, provide information about shopping. And then we have search engine marketing, search engine optimization, search engine algorithm are different things. Search engine algorithm is the algorithm which are being used by the search engine to, what does it used for? It is not about crawling, it is about ranking. Search engine, because they search the index. After they search index, they need to rank. So that is the search engine algorithm. So different search engine will have different search engine algorithm. Search engine optimization is linking, is actually not linking farms. Is relate to how do you make sure that you stay up, your website stay up in the ranking. How do you make sure, how do you promote so that your website stay up in the organic ranking of any particular search engine? Because most prominent search engine today is Google, so everybody will try to look into Google, but Google keep changing their search engine algorithm. So, so you need to know how, you need to get updates on their method of ranking so that you will design the content. Yeah, they look into two things: the keywords. They still use keywords. They look into metadata, and then they also use semantic entailment. Semantic entailment is when they look into content, your content, to determine the semantic of particular words. For example, we talk about construction, then your content of your website will be related to the construction so that they can infer the semantic of that particular content so that when people search for the content and then it will try to match up the semantic. Yeah, so Google is moving into semantic search. And then search engine marketing is applying search engine optimization for its marketing activity. So I think we will learn this more in digital marketing, yeah, digital marketing topic. This is taught, which has been taught, I think, by Prof. Some Prof. Abu Bakar. Yeah. Okay, then this is how Google work. This is Web 2.0. What is Web 2.0? What is the difference? Okay, before Web 2.0, anybody remember Web 1.0? Anybody remember Web 1.0? What time is it now? Well, anybody still use Web 1.0? Alia, are you using Web 1.0 or Web 2.0 today?
I don't know. We have.
Or Web 3.0?
Bro, I don't even know what is 1.0, 2.0.
Okay. Okay, when web started, it is Web 1.0. Of course, when it is started, nobody call it Web 1.0. Whenever people think started, for example, the Industrial Revolution, you remember today we call it in IR 4.0. Do you remember Web IR 2.0, 1.0, 3.0? No. Suddenly you have IR 4.0. Same goes to Web 1.0. We have Web 2.0. It created the term created by O'Reilly. It relates to social media, but before that, social media, the other webs that we use are called web, World Wide Web. The other web, and then suddenly those webs are becoming Web 1.0. Web 1.0 is web, the normal web that we use today. All the corporate webs, all the banking webs, all your personal website, even your assignment, you are developing the web, that is Web 1.0. Web 1.0 is where the server provide content to the audience. Server provide content to the audience is called Web 1.0. But then comes to contents like yeah, suddenly we have contents like YouTube, contents like Wikipedia, contents like Facebook. Oh, before Facebook, what do we have? Facebook, yeah. Before we have Friendsters. You know that one of the founder of Friendsters is a Malaysian. And then we have MySpace. Then we have Facebook. Facebook. Yeah, Facebook. We have Twitter.
All the chat punya channels dulu tu masa pakai MIRC.
This is not web based kan? Yang tu bukan web based.
Oh, okay.
Kan? Dia text based. MRC is internet relay chat. Dia right on the internet is actually a text based. It's not internet on the web. What else? Instagram. Now we have TikTok. Yeah. So with the advent of this thing, what is the features of this? The features of this is it enables collaboration. YouTube doesn't have content. Wikipedia doesn't have content. Friendster doesn't have content. MySpace doesn't have content. Facebook doesn't have content. Twitter doesn't have content. Instagram, TikTok, none of them have content. Whose content are there in their website, in their portal? Whose content are there?
Users.
Users content. That is second generation service. That is Web 2.0. Web 2.0 is where users put in content. So it enables collaboration, sharing information, yeah, that they creating new services online. Where users, they call it create content. They call it, the term is called co-creation. Actually not co-creation, we are creating the content. They don't have any content, they just put it, they just manage the content. Co-creation. Yeah, so the term is co-creation. So the features of this Web 2.0 is interactivity. You can adjust your content. Yeah, you can edit. For example, you can put up in YouTube. You can edit, and Wikipedia. That's why when you talk about references that you cite in your academic, you cannot use Wikipedia because this user's content. The people might not have authority to write about the content, but they write content in Wikipedia. Not reliable. So they have real-time user control, they have social participation. Of course, all of this is about social participation and user-generated content. User-generated content, you cannot control. So this is the Web 2.0. So Web 2, it's wrong to say some people thought that when we have Web 2.0, there is no more Web 1.0. Web 1.0 is still there. Web 2.0 is particularly for this type of content. All the corporate websites are still Web 2.1.0, it's normal web. Yeah, only the technology is different. We have Ajax, we have a lot of tools that maintain for the current web. Web 2.0 also is meant for different purposes. Any question on Web 2.0 before we move into Web 3.0? Okay, so Web 1.0 is one way, Web 2.0 is two way. So what about Web 3.0? Okay, this is example of Web 2.0, blogs, wiki, social. So we have discussed about it. And the Web 3.0, the next or the future web is called Web 3.0, where we have Internet of Things, Internet of People, increased cloud computing. Web 3.0 is where machine to machine. Machine can talk to another machine without human intervention. Yeah, so Web 1.0 one way, 2.0 two way, but 3.0 will remove the human. Machine can talk to another machine.
This is what they call machine learning, Prof.
Machine learning. What is machine learning?
Machine interacting with other machines in a language that both machines can understand.
Machine learning is actually related to data mining. Sometimes the name got confused. Machine learning is about is related to data mining, where the machine learns, the machine has some purpose, and then it learns. It doesn't learn from another machine, it learns from the data. So we discussed about data mining just now, but we cover machine learning. We can cover the machine learning in our Actually, it's not even in our data mining course. We can add that. But machine learning is more towards learning from the data. The machine learn from the data. So machine learning. But Web 3.0 is machine talking to another machine. Machine can communicate with another machine. For example, we have IoT. What is IoT? Where we Internet of Things. Is where we have, say, when you go in your house, you once the, uh, they can detect your retina or detect your biometrics, for example, your fingerprint. You can open the door, and once you are in the door, they detect that your body heat, so it will act on the air condition. So when you move from room to room, will detect, and then when once you close the door, or if you forgot to close the door, it will close by itself because the sensor detect your body heat, you're inside the house, and then your door is still open. So the sensor will tell the door, please close with the door. So the door will close by itself. So machine are talking to another machine. Yeah, so what is your routine? Say you move to another place, and then the sensor say, okay, you are in this room. They switch on the light, switch on the aircon, and then so this machine will be talking to the machine. And then you pull out the chair. If you see some video that the chair can sort by itself, yeah, can tidy up by itself and so on. So these are Internet of Things where machine are talking to another machine without human intervention. They have their own IP address, so they can communicate. Even you from far can communicate with your machine, and then the machine talk to another machine. That is Web 3.0. Pervasive web, Internet of Things, Internet of People. So you have increased cloud computing, ubiquitous mobile connectivity, greater seamless of web as a whole. So all this web, all this machine can run on its own. It will be fascinating.
So this is something like what Google and all the West countries are already doing lah. Like they have the Alexa tu kan, speaker that can control your
Alexa
home
is
system.
Alexa is a combination of natural language processing, and then it's actually artificial intelligence. Alexa, yeah, not so. So Web 2.0 is where machine can talk to another machine, and then they can process using. Do you watch Terminator?
Yes.
So that's how machine can talk to another machine. Okay.
Prof, the Web 3.0 not necessarily need to go through internet, right? They can have a direct communication between machine and machine.
They go through the internet.
So they still must go through the internet.
They still must go to the internet. It pass through the web. Web 3.0 is web-based communication. But okay, you must be clear. Web is not the thing that you see on the browser, meaning that it doesn't pass through the browser. You don't have to. They don't have to display anything on the browser. Actually, for example, you look into XML. XML, you cannot see anything on the browser. JSON, you cannot see. It's just line of codes. You don't see them on the browser. Our browsers are meant for human. Web 3.0 is machine talking to another machine over the web, but they don't need human to interpret. Yeah. Okay, any question? Alia, okay, Alia? Are you involved in this, Alia?
No.
Okay.
Doctor, if let's say like now have the technology like before I reach home and then I open the aircon at my phone apps, and then the aircon at my room already open after I reach my home. This is not the Web 3.0 because we still need to control the things, is it?
If you still need to control, then not Web 1.2.3.0 is actually we can initiate it by human, but after that machine can talk to machine anymore. Because there are tools that you can buy. Tools that you can buy. You can explore on your own. Because even in Facebook there is a group. You can find tools like Arduino. You can buy. You can have Raspberry Pi. Have you tried? Alia, you're a technical person, kan?
No.
Yeah. Oh, you're a technical person. You can try Raspberry.
I heard of Raspberry Pi. My technical team use this Raspberry Pi
Raspberry Pi,
virtualization.
Arduino.
Yes.
Because
I don't know what.
I'm thinking of installing it in my switch so that I can put some voice command. Please switch off the light because my wife coming. Who is going to switch off the light? You or me? No, I'm already asleep. You will switch off the light. Nobody wants to bangun and go to the light and switch off the light. So if we can just say, oh, you switch off the light, then they need to have a voice command, and the voice command need to be connected to the switch, and then the switch we can install with Arduino or Raspberry Pi. So that's it. Raspberry Pi is not a pie, it's not a pie that you can eat. So it's a software. It's a hardware actually. So you can say, okay, switch off the light, and then when you switch off the light, and then you can control. Say you can control like whenever I on the aircon, I switch off the fan, or I on the fan, I switch off the aircon. Can we do that? So the aircon need to communicate with the fan, something like that. We can use Arduino or Raspberry Pi to control the regulator or something like that. Okay, any question? So that means actually you can do by yourself. You can explore. The equipment you can order. Actually, you can order this equipment online, and then you can play around. You can have a smart home.
Of the level of technical haven't reached like yours. We all still this one blur already how to make ourselves.
Doctor, those of like smart bulb, all that, is that IoT?
Smart bulb, sometimes we call it smart, but it is actually, it's not not all smart equipments are based on IoT. One thing about IoT is there must be internet of things. So when there is no internet, it might be smart, but it is not internet based. For example, like there are smart mechanisms that can monitor the humidity, yeah. They can monitor the temperature, they can look into time or sensors. They have sensors and those, but it is not based on internet, so it is not IoT. But not all the time we will require IoT. IoT is where you need communication. You need your device to communicate with another. Sometimes there is a sensor, but you want the sensor to communicate with another device. So you give to this sensor an IP address, you give to the other device an IP address so they can communicate with each other. That is IoT. It doesn't mean that when it is not IoT, it is no good. It depends on what you need. Yeah. It is smart, but doesn't mean IoT is smart as well.
Doctor, is it mean like the exercise record in our smart band then can transfer to our device, the apps?
Can with this over the web, then it can be, but IoT runs on IPv6. They have their own. They use IP address. Yeah, they have a specific IPv6 address. They communicate directly. But there are also there is a system what we call it PAN. It's not covered here. PAN. PAN uses Bluetooth. Actually, it's supposed to be in the note. Oh yes, I think it's later. Sometimes when you are in a car, when you are within certain devices around you, we have LAN, local area network. We have another we call it personal area network. Personal area network is your devices are connected with each other using Bluetooth. The term is called pairing. You pairing, you get a number, you pairing. So and then you have equipment surrounding you. That is personal area network. It is not based on internet. It is using Bluetooth. Okay, move on. So okay, cellular system. We have covered cellular system just now. We have LTE, WiMAX. We have Bluetooth. Okay, this Bluetooth is what we call personal area network, PAN. The standard set for personal area network is 802.11. This is ITU-T standard, International Telecommunication Unit. ITU, telecommunication, telephony standard. Yeah. Now I think they call it differently. But ITU has changed the name. Yeah, ITU. And then this is WiMAX. WiMAX, for example, like we have P1, we have earlier P1. What else do we have? We have Yes, P1, Red Tone. Yeah. Not many survive. Not many companies survive. Yeah. Several companies got the WiMAX license, but not many companies survive. Okay, this is personal area network communicating using Bluetooth. Yeah. This is wireless LAN. And then radio frequency identification. Radio frequency identification is an identification using radio frequency. It can be 73. I once have this 73 digit identification alphanumerical. So it's difficult for people to communicate. So, but you can, but there are two types of RFID. One is called passive RFID. The other one is active RFID. Passive RFID is they wait until the interrogator. The term is interrogator. The interrogator will interrogate the tag. There is a tag. Yeah, the tag. The interrogate the tag, and then to identify the tag. For example, when you're passing through certain certain shops like Watson, there is a gang gates. So if you pass through, if you don't pay, you pass through, they will sound, the alarm will sound. So it is a 1 bit RFID, 0 and 1. 0 not yet paid, 1 paid, vice versa, I'm not sure. But only 1 bit RFID. So when you buy your things, they put it on a magnetic plate. The magnetic plate will change the 0 to 1. So when you pass through the gate, it doesn't, the alarm will not be activated. But if you they forgotten or they didn't put it on the magnetic plate, you pass through the door, the alarm will sound. So that is a 1 bit RFID. It's more simple. Besides that, in your library books, there is also RFID. In your toll gate, for the tolls, there are two types of RFID. There are this active RFID and passive RFID. The current one, the new one is passive RFID, where the gate will interrogate the tag. The old one is an active RFID. Active RFID, they have a battery, they have power, and then they will emit their signal to the interrogator. The interrogator will accept the signal, yeah, and then release. So it can carry some data information in the RFID tag. But there are some RFID tag doesn't have data. There are some with data. Some just with the name, with their ID. Some with have additional data. So RFID is good for this automated toll collection, tracking of goods in supply chain. Yeah. So there is one case if you read the case of Mercedes-Benz, Daimler-Benz. Daimler-Benz installed RFID, weatherproof RFID, essentially placed into at their chassis of the car. So they provide the ID for the car. I mean, since the construction of the chassis, and then the buyer of the car, the purchaser of the car will know what is the progress of the car, when it will be delivered, whether it is in the paint shop, whether they are installing the equipment and so on, until they receive the car, and then it will be installed with the plate number, and then they will detect, okay, they will synchronize the plate number with the RFID number. And then, but once you sell the car, say you want to keep your plate number, so the car will have a different plate number. But still, if the car, I mean the new owner visit the service center, they will still be able to detect the car, not by the plate number, because the plate number has changed. They will detect the car by the RFID. And so the RFID is still there. It is a passive RFID. Okay, this is how RFID work. They have a tag, they have a reader. Sometimes we call it interrogator. Yeah, they call it interrogates. Okay, this one interrogates. Sometimes we call it reader, but sometimes we call it interrogator. They interrogate and decode the data. And then once they decode the data, sometimes there are additional data in the RFID, but at times it is just the ID. The basic one just have the ID. The rest of the data is at the computing system, at the information system, at the IS. They require an IS here. Yeah, IS. So that is RFID work. That is how. Any question? Anybody have been using RFID? Everybody actually. Huh?
Yes. Smart tag. I mean,
smart tag.
Smart tag tu ya, RFID.
Smart tag is a smart tag. The old smart tag is a passive, is an active RFID. The one that now recently installed is that one is a passive RFID. Both are RFID.
Tapi kenapa the RFID yang foto tu it's not as reaktif? Apa dia macam slow, dia macam
yang baru yang lama.
Yang baru yang tampal dekat
okay, yang baru tu dia yang the new one is called passive RFID. Dia tak ada bateri.
Yes, dia tak ada bateri.
So dia tak ada bateri, dia passive RFID. Passive RFID dia tunggu interrogator to detect them. But active RFID they emit their signal.
Oh, ke sebab dia punya distance tu ada kena mengena dengan the RFID reader, like you know, because macam kalau dekat US kan dia punya RFID is so, maknanya you don't even have to slow down. Kita kat Malaysia kena slow down, even Singapore pun faster I think.
Dia interrogator and the system, they both we don't know which one is the fault one. The faulty one. Okay, when the car pass through, when the car come nearby, if you use an active RFID, it will emit your signal. The active RFID, with the one with the battery, will emit the signal. And then the interrogator will intercept the signal and then identify the car, actually they don't identify the car, they identify the RFID. Identify the RFID and then it will be processed and give instruction to the gate to open or not. That is how it works. But if it is still, passive RFID can also work, but you need a stronger interrogator. Or interrogator should be placed somewhere before the gate, not at the gate, before the gate. So when it comes nearby, it detects first, and then send signal, and then so it depends on the interrogator, the RFID tag, and the system. Okay, does that answer you, Alia?
Yes, yes.
Yeah, can. Okay. I pun tak tahu sangat sebab I tahu this RFID because I've been trying to selling RFID tag to because the case of the mention just now the case of Daimler Benz I've been trying to sell RFID tag to our car manufacturer but I was from the industry kan jadi but they didn't buy.
I know a lot of place there are laundry also have RFID tag.
Which
Like
one? Yeah.
hotel, nursing home,
Yes.
they have their laundry, everything with the tag.
Yeah, because because I was promoting RFID when it was first come into place, when the technology was new. When the technology was new, it's not cheap. But today RFID is getting cheaper and cheaper. So back then when I was trying to sell, the price is quite high and say, oh we want to. But I pun tak banyak je, RM20 saja for any car. Sekarang if you can tambah ini RM20 in your car, and that people can come and service and so on. But okay. But today RFID cheap. RFID is not that expensive. You know. But it's not just about the RFID. It's about the information system as well. Yeah, and then it's also about the reader. We need to place the reader. The reader RFID may be cheap, but the reader or interrogator, the system, not that. Okay, any other question before then we have wireless sensor network. Like someone asked just now whether sensors or things not all sensors are IoTs, but sensors can fuel this IoT. You can use sensors to detect certain information, and then you can use it to pass information to another system or the computer or another device using the IoT, and then you can gather the data from the sensor. These are for unstructured data, so you can process it to become to be in the big data. So this is wireless sensor network. Wireless sensor network is the sensor that you put in at your home or to prevent burglary, for example, heat sensor, yeah. Or we also have sensor to prevent, say, landslide, yeah. Landslide, we have sensor to prevent landslide, so we can detect movement of the earth, sensing GIS, yeah. This is wireless sensor network. And that's all for this for today. We are 12:30. We are early. Any question? We are early by 45 minutes. We have 45 minutes more.
Prof.
Cookies.
Yes, cuti
Prof nak tanya, kalau cookies tu dengan crawlers tu, is it different or is it the same thing?
Macam mana? Crawler dengan?
Cookies dengan crawlers.
Okay, cookies and crawler. Okay, cookies is actually the cookies is a data they put in your system. They place the data in your system. It is not crawler. Crawler is they crawl, they pick up data from your system. They pick up data from your system and then they keep it in their server. And then they index it. Index, what is index? Index is something like you see at the back of the book. You have a book, at the back of the book, that is index. Exactly, that is the same index because they have this name character and then they have a URL. Name, URL, name, URL. So that is how they index. Name, URL, but they put everything. That is the index. The crawler develops the index. But cookies is they install information. Once you visit their site, you move within their site, they store that information, who is your name, your IP address, and then certain information about you, and then certain number. They have a number, and then this is we call it the foreign key, the primary key. They keep it inside your system. And then when you visit their server again, they will look for that cookie. Once they got your cookie, and then they say, last time you visit this site, you want to buy this thing. Do you still want to buy this thing? And then you can say, oh, Miss Habibah, welcome. It's long time. Your last visit is so and so. And then say, oh, how do they know your name? My name. Say, okay, that is how cookies work. They install it in your system, whereas crawler is different. Crawler is picking information, fetching information from your system. The other way
So
around.
then cookies is similar to shopping bot.
Cookies is similar to shopping bot. Shopping bot is a robot that when you visit, they actually it help you to do shopping. Help you to do shopping. They combine it. They have a system that combine. They can place cookies in your information, or they have this. They reside in their server.
Oh, shopping bot uses your cookie to recommend what.
Yes, they can use their keys to recommend, and also they also reside that shopping bot. Yeah. Okay. Any other question?
Betul. I have a question regarding individual assignment. Do you for the assignment, do you need only the screenshot, or do you also need to access the website? Because I don't know why, but I have created like 2 or 3 like that. But then WordPress keeps on suspending my website. I think because of, I don't know, copyright of the pictures I put inside.
Okay.
But then I sempat screenshot lah.
Okay, tak apa, nanti you just send it to me. Because I think when you put images, you can get from Shutterstock or some images which is free, or you can get from Google. Certain images, especially certain content, there are copyrights lah. Even for example, when I put up my content, our class content. Our class content is you can retrieve it from, you can watch it over, I put it over learning, but it is actually placed in YouTube. It is placed on YouTube, actually linked to YouTube. There are some content, for example, during class, we put up videos. For example, we have videos and metrics and so on. It is filtered. It was filtered. So it is in the recording, there is no Matrix movie or it is filtered by. So okay, just send it to me first. Okay. Any other question?
Doctor, just want to ask for the RFID, because now I see some housing area, they don't use the card, physical card, but then they change to the RFID tag. Then the housing area have 2 blocks. Means the first one you sense and open, then the second one sense and open again. I just want to know, is it these 2 is linked? Then maybe when they link, then okay, they first detect you in the first gate. Then when you go to a second gate, maybe they no need to take so much time, and then they can quickly open like that. Is it the link, or just or they need to sense again?
Okay, they need to send again because RFID is detecting the ID. RFID is just detecting the ID. You detect first, then they will send to the server. Or there is a system that might not be a server, maybe a PC, but PC is still a server. So, and then they say, okay, this person is in, and then you want to go out. They say, okay, allow you to go out. There are servers that doesn't allow, not the RFID. You must remember, RFID is just giving out the ID. There are systems. If I develop system, I wouldn't allow 2 IDs to come in without one going out. For example, Tan Chao Hua come in. Next hour, Tan Chao Hua come in again. Hey, how come you come twice? You didn't go out. So the second time I will not allow. So you have to go out first and then you can pick up. Then only you can come in. But it depends on the system. It depends on the system. Because RFID is just emitting the identification. It's not about RFID. It's about the system. Okay. Any other question?
Doctor, ada lagi satu question. And then how about the, kan some wallet, they said there are RFID block macam tu.
Okay, RFID block indicate wallet that there are RFID block. Okay, in your some of your cards, they have RFID, especially those that you use for PayWave. PayWave have RFID. So how do you make payment for your McDonald's or anything? You just wave, right? You wave, they detect the RFID and then they charge out. The RFID is really detecting the card. It's not detecting the money inside. But once they detect, you can limit, say about 200. The best that you limit. Maybe 100, 250 ringgit. You have to limit the amount that you allow for PayWave. Exceeding that, it's better that you use. I would recommend that you use PIN. Yeah, you don't allow PayWave to be. So when you do a PayWave, so they're detecting the RFID. Okay, I'm not sure whether this RFID wallet really works or not. Okay, there are people who pass through and they carry equipment, yeah, pass through your maybe you are sitting somewhere in shop lots and say they pass through, they detect your RFID, detect your PayWave RFID, and then they can create the card and then they can spend money, they can spend your money. So that's why they have this RFID wallet, so that this equipment trying to detect, they have a block, they block. So they will not be able to detect your number, your ID or your PayWave. Yeah.
Tapi kalau kita yang tak pakai wallet ada RFID block tu macam mana? What is the safety
features macam mana? The safety feature you limit lah. You limit your PayWave.
Now kan limit, I mean the highest that you can go pun sekarang is 250 kan. Tapi scary jugalah kadang-kadang.
I pernah satu kad saya block langsung, tak ada. I just use PIN.
Oh.
If you're afraid, you just use PIN lah. PIN is safer. Kan?
That's why now when you PayWave, you will get message from your bank. Yeah, so basically just like last time credit card, this credit card also have the same problem when people take your card and they just swipe. So now it's the same problem with
PayWave
technology, different scenario.
Yeah, but yeah, go for the bank and the bank say we will investigate. It's up to you lah, actually. But you be wary lah when people moving behind you.
Because there is certain distance kan, it needs to be like
there's a certain distance. Yeah.
They need to be really close to us.
Yes, they need to be really close to you.
It's not that easy to steal the RFID. The bank and have a lot of technology security behind all this, so it's very safe actually.
Yeah. Yes. But I'm not sure. But we just prepare lah. I mean, we don't have to. You limit your. Of course, maximum is 250. But I still at times I still use PayWave. But there are some cards that I use PIN. Depend on you. Okay. Okay. Any other question? Otherwise, we can adjourn for today. We meet again. We don't have. Do we have class next week? Yeah.
No.
No. Yeah. Okay. Next week we don't have class. We meet again on the. On the 21st. We meet it on the 21st. Hopefully the MCO ends.
Inshallah. Hopefully. It doesn't look like it though, tapi keep our fingers crossed.
I'm getting bored. Have you done your vaccination? Anybody? Not yet. Emmanuel, done your vaccination? AstraZeneca?
Pfizer.
Pfizer, oh, okay. Anybody else? No.
I got mine AstraZeneca 2 days ago.
AstraZeneca 2 days ago.
You register or they give you?
I registered, I fight for the first round though. Fighting macam so we got for all my family members, so about 7 of us now already vaccinated for the first round.
Okay, hopefully we overcome this soon. Okay, thank you very much. Assalamualaikum.
Thank you, Doctor.
Thank
Bye,
you,
everyone.
Doctor. Bye-bye.
Thank you, Prof. Bye, everyone.